Hey guys, this is the video for the last 4 questions of the assignment for this week. We're looking at questions 17, 18, 19, 20 here, and we're being asked to solve the triangle. First thing you need to understand about solving triangles is that that means we need to know all 3 sides and all 3 angles. You can write them in. It's a little hard to cram angles in. They tend not to have a lot of space. I'm a big fan of just writing capital A is this, capital B is this, capital C is this. Little a, little b, and little c. Now, in this assignment, not on the next assignment, but on this assignment, you'll notice they're all right triangles. That's going to help solve us a bunch of problems by just allowing us to use basic trigonometry. And so I'm going to look through 2 example problems. And to look through 2 example problems on the side here, hopefully that will answer all of our concerns and needs. We're going to probably need Desmos along the way. I'm going to grab that. And I'm going to remember that I'm probably going to need to switch it into degree mode at some point. All right, so that's set for me. Let's take a look here at the writing here on the side. And I'm going to try to do this so that we can kind of see both screens, at least for the moment. Let me jump over here and maybe move this over to here. And since we don't really need the graph, we can kind of come down to that size. All right, so this is pretty good. I think we can get both screens on here. All right, so what we're going to start with is this first question where we have a triangle. It's a 90-degree triangle with a 30-degree angle here, and we have one side, only one side labeled. You'll see some of these on your homework. And so if I'm going to list off some information, first, A is 30 degrees. Capital B isn't known, but since I know that C is 90 degrees, I can subtract from 180 to get 60 degrees for little b. Now, I also know that across from big A, there's a 2. That would be represented by little a. Okay, remember this is little a, this will be little b, and this will be little c. When it comes to solving for little b and little c, what I'm going to want to do is use basic trigonometry. Now, I want to acknowledge, depending on which side I pick, maybe I want to pick angle A, maybe I want to pick angle B, but I'm going to just pick an angle and then reference everything from there. So I'm going to go ahead and select A as my reference angle, which would make this the opposite side, B is the adjacent side, and C, of course, is the hypotenuse. That means that when I set up my trig problem, in order to find B, the adjacent side, which I don't know, I'm going to have to use something that I do know, the opposite side, which is 2. So this would be a tangent that uses opposite and adjacent. I'm going to grab a new piece of paper here, just kind of write down below this. So I can say that the tangent of my 30-degree angle is equal to the opposite side, which is 2, over the adjacent, which is little b. Now to solve for little b, I'm going to do the old Welch and have it say b equals 2 over the tangent of 30. Now that's something that can go into my calculator over here. We've got 2 divided by, and I'm just going to grab the function here, tangent of 30. I get 3.46, we're going to call that 3.5. So over here, we can come in and say that b is 3.5 inches or units or whatever it is. Now you could technically use Pythagorean's theorem. Feel free to do that. A squared plus b squared equals c squared. However, I'm a fan of just using the trigonometry. I would need to use a hypotenuse, and I like using the opposite side because that 2 is not a rounded value. I like the perfect value of 2. So over here, what we're going to do, slide this up for a little bit, is we're going to say that if we're using the opposite side, that would be sine of 30 is equal to the opposite 2 over the adjacent, or over the hypotenuse, which would be c. Again, we do the old Welch to get that little c is going to equal 2 over the sine of 30. And so we're going to come over here. I'm actually just going to go boop, 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 and insert the function sine. And I end up getting 4. My hypotenuse way up here for C is 4. I found all 3 sides and all 3 angles for that triangle. And so my answer is complete. Now that's an example when you're given one side and one angle. Actually, technically 2 angles, because you know one's a 90. The other case that you're going to be looking at is a problem where you're not given any of the angles except for C being 90. So I'm going to come over here, we'll say A equals unknown, B equals unknown, and C equals 90. But they do give me little a is 4, right? Because opposite of A, opposite of big B would be little b, which is 7. And then I'm missing little c. Now, I'm just going to tell you right now, there's not going to be a quicker way to find c than using Pythagorean's theorem. And so I'm going to come over here. Let's start a new problem. We've got 4 squared plus 7 squared equals 65. That makes c the square root of 65. Now, traditionally, we would write it as root 65 if we had a reason that we needed an exact answer. I'm actually going to say that we can avoid using exact answers here a little bit because these are actual measurements from a triangle. So let's just take the square root of that 65, and we get 8.06. We'll call that 8.1. If I was asking you to stack the sign, like sine is this over that, again, using decimals there are not ideal, but I think we can avoid it here. All right. So the next thing we need to do is figure out these other angles. Well, if I'm looking for, say, angle A, I know the opposite is 4 and the adjacent is 7. I also know the hypotenuse is the square root of 65. But the point is, I do know the opposite and I do know the adjacent. That is the tangent, okay? So if I took the tangent of an unknown angle A, all right, it would equal the opposite side, which is 4 in this case, over the adjacent 7. Well, we learned about this in the last video. If we want to get rid of the tangent to find the angle by itself, right, all we have to do is use the inverse of the trig. So if we take an inverse with tangent, then our angle is left alone. And angle A would be the tan inverse. So we're going to get out of this guy. Get out of this guy. All right, functions. We're going to look for the tan inverse of 4 divided by 7. We end up with 29.7 degrees. All right, so I can come up here. I can say A is 29.7 degrees. And I know that my angles have to add up to 180. So if I take 90 plus, 29.7, and I take 180 minus that 119.7, I get 60.3. The angle B has to be 60.3 degrees. And again, we found all 3 sides, all 3 angles. This is an expectation you should have on a test. Yeah, for sure, we're going to give you questions where you're going to be asked to find the angles, find the sides, find different information. Hopefully that's enough to give you the support that you need, and come ask questions during the live sessions.